Hello students, welcome to the next class of force. So, have you properly gone through the previous two videos of force? Now the next is pressure. Let us recall what we had learned in force. So, an interaction of one object with another object results in a force between two objects. When we apply the force, motion is imparted to objects was due to the action of force. We had already studied that force applied on the object in the same direction are added to one another. Also, if two forces act in opposite direction on an object, the net force acting on it is the difference between two forces. So, the net force on an object is zero if two forces acting on the object in opposite directions are equal. So, in general, more than one forces may be act on an object, but the effect on the object is due to the net force acting on it. So, this is basics of force. Force applied on an object may change its speed. So here we are talking about the state of the object, whether the object is in rest or in motion. If the force is applied on the object, it changes its direction of motion, or if the speed of the object will increases if the force is applied in the direction of motion, and the speed will decreases if the force are applied in the opposite direction of the motion. So, application of the force may changes its speed and direction. Secondly, the application of the force on an object may changes its shape, and this is we had studied in the previous video. So, force may make an object to move from the rest. Force may change the speed of an object if it is moving. It may change the direction of motion of an object. Force may bring about a change in the shape of object. Also, force may cause some or all these effects which is indicated above. So, without force, an object cannot move by itself. Without force, an object cannot change its speed. Without force, object cannot change its direction. Also, the shape of the object cannot be changed if we are not applying the force on an object. So, this is all about force that we had studied. Now, the next topic is pressure. Okay, see, few more topics we had learned. Let us recall it again. That is contact forces. The force resulting due to the action of muscles, that is called as a muscular force, because we need to be in touch with the object to apply the force on it. Similarly, the frictional force, it is also the contact force. So, contact forces are the forces in which we need to be in contact with the object. Then the non-contact forces. The non-contact forces are the forces which is applied without being in contact with the object. That is the magnetic force, electrostatic force, and the gravitational force. So these are the three forces in the world are denoted as a non-contact forces. Okay, now the new topic is pressure. You can see the two figures indicated here. What can you see in that figure? A man is trying to pushing a nail in a wooden block by its head. Try to do the same with your own. Can you push the nail into the wood? No, you cannot. Why? Because you are trying to push the nail with its head. Now, try to push the nail by its pointed end. Which one is easy? So the easiest way is when you are pushing it with the end of pointed end. In your kitchen, try to cut the vegetables with the blunt knife. Blunt knife એટલે બુઠ્ઠી છરી. ઘરમાં જે છરી વપરાય છે એને બે ધાર હોય છે, એક બાજુ બુઠ્ઠી હોય છે, બીજી બાજુ ધાર હોય છે. So blunt knife, and then you take another knife which is sharp. Try to cut the vegetables by both of them. In which way you can feel the easy to cut the vegetables? Yes, with the sharp knife you can cut the vegetables within very easy. So here what we are doing, we are applying the force, but when the applicable force is distributed over the large area, then the pressure will be reduced. So here we can define the pressure as force per unit area. So here what happens when we are trying to push the nail with the larger area, that is the head. So what happens here, the same force but it is distributed over larger area, so pressure will be decreases. So here the nail cannot be pushed, but when we are using the pointed end, the area of the pointed end will be very less. So here the pressure will be very large for the same force. So the nails can be easily inserted into the wooden block. Okay, what you can see in these two figures. In these two figures you can see that on the left hand side you are applying the force which is not perpendicular to the surface on which we are applying to pressure. But in this second figure you can see that the nail is very much perpendicular to the wooden block. So in this standard 8 we are limited to our study, for we are considering only those forces which is acting perpendicular to the surface on which the pressure is to be computed. So now again define pressure. Pressure is equal to force divided by area. Note that the pointed nail, the area is in the denominator in the above expression. So where the area is smaller, the pressure will be the larger. So the area of the pointed end of the nail is much smaller than the head. So for the same force, the produced pressure is sufficient to push the pointed end into the nail into wooden block. So this is what about the pressure. Now answer the following question. Can you explain why your shoulder bags are provided with the broad straps, not with the thin strap? તમે જે સ્કૂલ બેગ વાપરો છો એને જ્યારે તમે ખભા પર અહીંયા બેગ પહેરવો છો તો એના પટ્ટાઓ પહોળા હોય છે. એરિયા વિલ બી લાર્જર. So you can easily lift your bag. But if you are provided with a thin strip, what happens? What happens that you cannot lift it back, but you can feel some pressure on the shoulder. Similarly, why the tools mean for cutting and piercing always have the sharp edges? So now you can easily answer that for the smaller force we can have a large pressure if we are having the area is small. Now let us see more. What you can see here in this figure, you can see there are two figures are shown. In the first figure, there is, you can take a transparent pipe and tie a balloon at the another end. Now fill a water up to some height. You can see that the balloon will bulge out. So what you can see, the water or the liquid can make a pressure. It will exert the pressure on the another end. Now try to fill the more water. So what you can see, the balloon will bulge more. So you can see here that the liquid can also make a pressure on the any surface. In the another figure, you can see that there is a small pipe or the small hollow glass tube which is attached here, and you can see that is we had filled a water to certain height. Now what you can see that the point A is the uppermost and point D is the lowermost. So what you can see, the water which is falling on the outside from point A, which is reaching to near, and when the water falling outside from the point D which is reaching to the large distance. So what happens here, the pressure is larger when the height of the water is much, and if the height of the pressure water is less, that is at point A, you can see that there is small pressure and the water cannot reach at the longer side. Similarly, you can see there is a figure of balloon. What you can see, try to inflate the balloon and push the balloon from the one side. So what you can see, you can easily push, but as soon as you remove your finger, the balloon can take its original shape. What makes it so? The filled air inside the balloon can create a pressure into the inside wall of the balloon. Similarly, in the second figure, you can see that a boy is trying to fill the air in his cycle tube. What you can do? The cycle tube will be filled by the some pressure which is done by the man. The third figure, what you can see, a person is trying to inflate the balloon. When you are trying to inflate the balloon, you can feel some pressure on the your muscles of your mouth. So it can see easily that whenever there is a large air is there, you can see that there is a pressure is happens. So this is what about the pressure by air. And the last topic is atmospheric pressure. What is atmospheric pressure? We all know that air is all around us, and this envelope of air is known as a atmosphere. So the atmosphere in the air extend up to many kilometers above the surface of the air. The pressure exerted by this air is known as a atmospheric pressure. Now see the figure below. There is a air sucker is there. In that air sucker you would observe many places when there is a glass surface and you are trying to hang something on it. So that is called the air sucker. Try to press the air sucker. What happens? When you are pressing the air sucker on a surface, the air between the cup and the surface will escape out. So now there is no air between the cup and at the surface. So what happens now? The pressure around the cup will be the larger, and that is what the atmospheric pressure. And now try to pull out the sucker from the surface. You can not make it easily. Why? Because when you pull out, you are trying to apply some forces on the sucker, but that the applied forces by you is much lesser than the atmospheric pressure, and you cannot easily pull it up. So this is what about the atmospheric pressure. This is one figure which is a historical figure. You can see two hemispheres are attached together, and on the both sides the 8 horses are there. They are trying to pull it. So this is what an experiment made by the German scientist in 17th century. He has invented a pump to extract the air out of a vessel, and with the help of this pump he has demonstrated the force of the air pressure. He joined the two metallic hemispheres of 51 centimeter diameter each and pumped the air out of them. And then he had employed the 8 horses on both of side of the hemisphere to pull them apart. And so the force of air pressure of that the hemisphere could not be pulled apart. So the air pressure is much larger than the other pressure, and you can easily that you can see the many of the heavy vehicles are equipped with the air brake. In the many of trucks and heavy vehicles you can see that there is an air brake written on the some of the tank which is given downwards. So this is the air brake. So air pressure is the largest pressure, and we can easily apply this on the application. So this is what about the chapter of force and pressure. So here we are ending the chapter 11, that is force and pressure. So what you have learned, let us recall it again from the start. Force could be the pull or a push. A force arises due to the interaction between two objects. Force has magnitude as well as direction. A change in the speed of objects or the direction of its motion or both implies there is a change in its state of motion, and that is because of the force. Force acting on an object may cause the change in its state of motion, or it can change the shape of the object. A force can act on an object with or without being in contact with it. We can denote it is as a contact forces and non-contact forces. Force per unit area is called the pressure. Liquid and gas exerts the pressure on the wall of their containers. The pressure exerted by the air around us is known as an atmospheric pressure. So here these are the main points that we had studied in the last 3 video classes. So now we give you some assignment, so you need to write it at your home. So thank you for attending this video class.